I'm a researcher in the area of engineering education, and I'm also administrator there at Georgia Tech. I'm in charge of the undergraduate program. A lot of the work I've done over the years, has been involved in hands-on education, really engaging people in the classroom. And so the project that I'm going to be talking to you about is combining a lot of things together. Blending of a classroom or flipping of the classroom, hands-on activities and MOOCs, all in a circuits class, and doing both online as well as on-campus learning. I'll give you a little bit of background of the environment at Georgia Tech. The innovation in education is something that's really important in our upper administration, and they've provided a lot of resources to that end. Part of what they've done is providing funding for MOOCs to find out where we can go with that. So they provided the resources to develop over 50 MOOCs at Georgia Tech, and we have 3 of them in ECE. There are, let's see if there's I'm kind of a person that likes to walk around. I'm having trouble doing this, so I'm going to do this a little bit. I've been involved. Okay, is that? Nope. I guess I'm going to have to be over here then. I've been involved in 2 of them. The ones on the left, the circuits, linear circuits, and introduction to electronics, along with a couple of collaborators. And the purpose of that was to enhance our on-campus education. So we wanted to flip the class with the MOOC. And let me tell you a little bit about our circuits classes. We have 2 circuits classes. One is the circuits for non-majors. This one is scale of about 450 students per term. Georgia Tech's a big engineering program, so it's 1,100 students per year, 26 sections per year. Some of the issues that we had prior to changing the format to the flipped format was inconsistency in coverage and grades across the different sections, and a lot of uneven quality because the instructors were not the same. And then the other class that we wanted to work with is ECE 2040, which is the circuits class for majors. And that goes into a little bit more depth. There's about 200 students per term, 9 sections per year of that class. So it's a very large scale to try to flip a classroom. Now, pedagogical objectives, one was large-scale teaching, large classes, large sections, to be able to improve consistency across these sections, both in quality and coverage. And the other thing is my personal interest was to introduce active learning and hands-on education to increase the student understanding and improve their attitude, especially when I consider the non-majors course. It's a service course for them. We really have to motivate them. And if you look at this, let's see, on the left, we wanted to have students engaged with each other during the class, and we wanted to have more faculty and instructor engagement with the students during class time. In order to set this up to flip the classroom, we had to create the videos. And so we had an educational research specialist work with us on developing these videos. And we used a lot of theory of learning to develop these. For example, students really don't pay much attention to passive PowerPoint slides. So if you insert a little video of the instructor there, that you actually get 2 benefits out of it. One, it brings a focus point for them. Something is moving and they can watch that and pay more attention. The other thing is they want to have a connection to the instructor. Another thing is that the videos are all about 10 to 14 minutes long because that's the attention span of most people before they start phasing out. Another thing is, as far as having things moving on there, we have a lot of the slides have partially written material on there, and a lot of the rest of it is written while they're watching it. So we've got somebody writing on top of the video so that they can actively be taking notes as they're watching, and they're a little bit more engaged in it. Another thing is that students learn by questioning themselves, by testing themselves. And it's called Formative Assessment. And in that, we have these little pop-up videos pop-up quizzes that appear throughout the video. That's like, okay, basic concepts. Did you follow what was just happening? And let's move on if you did. So all of that was building upon educational research in creating these videos. The class structure at Georgia Tech, so we use these videos to flip the classes. Both classes, the non-majors class and the majors class. And the online material was provided through the MOOC. We had the video lectures. We had all the extra worked problems. We have about 100 videos of professor working problems and explaining it. All the homework is on there. It's graded automatically, so students immediately get feedback whether they got it right or wrong, and then they get multiple chances to be able to correct themselves. And I have people doing much more homework and much more intent on getting their homework done than normally because of that immediate feedback. We have end of the module quizzes. Now, we offer this as a MOOC to the public, so it's two formats, a MOOC to the public as well as to the on-campus students. And the on-campus students, the end of module quizzes are just for their benefit, formative assessments. It doesn't go into their grade. It is graded for the public students. We also have a Piazza discussion forum, which is shared between the Georgia Tech students and the public students. So there's shared homework. So the MOOC is operated synchronously with the on-campus students. 450 in the majors class, 110 in the non-major, 110 in the majors class, 450 in the, anyway, 550 students on campus. I can add, 550 students on campus. And right now, this semester, we've had 34,000 people in the public taking this class synchronously. And they share homework and they share the discussion forum. So in class, the Georgia Tech students in class, here's the format of the structure. They start with a 2-minute quiz on the lecture material to make sure they're keeping up with it. Basic concept type of thing, just to make sure they're keeping up. Then we have some mini lectures to give more depth of the material, things that were not covered in the lectures, or to work extra problems, more difficult problems. We have some time for question and answers. They do worksheets on the more complicated material. Some of the worksheets are sort of design-oriented, how would you use this in a real application. Some of them were just more detailed problems. And hands-on activities, this is a big thing that we're able to do in electrical and computer engineering that maybe some other fields aren't. We have these little devices that the students own. They're called National Instruments MIDACs. They buy that and they buy a little circuit board, a little circuit breadboard and parts kit, and they actually sit there in the class. This is an example in the classroom where they're working together on the little devices doing experiments during class. In my circuits for the majors class, every Friday is the MIDAC day. So this is a lecture-based class, no lab credit, but every Friday they're doing lab experiments in it to enhance the learning in the class. I've also offered a distance learning section of this class, completely distance learning, Georgia Tech class, where they had their devices and they were wherever. Was one student in India, there were students in California, I'm in Georgia, all over. And they're having to do these labs on their own. And they go onto an online site, online meeting site to demo it to the instructor. And they actually use the discussion forum to post their breadboard and say, something's wrong. Can somebody tell me what's wrong? And other students would get in there and say, oh yeah, your wiring here is mixed up. Or they would show their screenshot of their oscilloscope and saying, is something wrong with my settings? I'm not getting something right. And other students would chime in and give the answers. Oh yeah, you don't have this setting right. So this is what we do. It's a very, very active class all the way through. And again, the scope of it, this semester, again, 450 students on campus in the majors, non-majors class, 110 in the core sets for the majors, 34,000 students in the MOOC classes. So it's probably, I think it might be the largest flipped class that's in the country in engineering. And the lessons learned, I wanted to talk a little bit about this. We've taught this now for 4 semesters. This is our 4th semester of teaching it. And we've evolved the process of the blending. We started with more or less a flipped model, which is a little bit more narrow. Blending means you're doing a lot more activities in class. And we've done a lot of feedback from the students as to what works and what doesn't work. And it's not all that obvious when you start out with this as to what's going to work. And we have tuned it. And it's kind of interesting that I also work with a lot of, since I'm an administrator, I work with a lot of other faculty in my department on how to do blending very efficiently. And it's not always obvious with people. The other thing that we've looked at was workload. We're able to get through so much more material this way than we can in a normal class, much more efficiently. We're able to do a lot of things in class, like all the lab activities, which we never had before we flipped the class. So I want to monitor the workload because this should not be more than a regular class, a 3-credit-hour class. So I adjust work assignments, I adjust homework and things like that. Other things I wanted to mention is students need to be taught how to learn this way. For example, take notes. I mean, it seems so obvious, but the first time I taught it, I had a bunch of students who never took notes because they figured, oh, I can just rewatch the videos whenever I want. I was like, okay, well, what do you do before the test? They had no notes. And then there were other students that were working the problems because all the problems were online. They would work the problems on scrap pieces of paper. Again, came time for the test, and they had none of their work. And so we had to tell them, first day of class, okay, to succeed in this class, take notes. Another thing is to work your problems in a notebook so that you can refer back to it. And that made a big difference. Another thing is instructors need to learn how to teach this way. It's not something that most of them have done before. They've never taken a blended classroom. And so they had to be taught how to teach this way, how to use their time in class most effectively. The other comments I want to mention is, so there's a difference between we're doing a MOOC and we're flipping the classroom. A lot of people flip classrooms without doing a MOOC. Why did the MOOC help us out? Well, the platform provided a complete learning environment. We were able to have these videos with the in-quiz videos that would, in-video quizzes that would pop up. And we also had them able to play the video at whatever speed they wanted. So some of the students played it at twice the speed if that was if they were fast students, quick learners. So it was really molded to their own learning style. And I couldn't have done that on my own. I didn't have the background and I didn't have that software on my own. So the MOOC platform was great for that. Biggest surprise of this, benefits of the Piazza Forum. The benefits of the Piazza Forum by working through the MOOC was tremendous because we have so many people out there in the public who really want to learn this stuff. They're taking this on their own just because they're interested. I have people who have a degree in physics and want to learn this, mathematicians, maybe they're engineers who just want to refresh their memory. And they get on this and they do the homework right away and then they're answering questions from the Georgia Tech students. So there has been a net positive from the public to the Georgia Tech students. These are like unpaid tutors. And there's people out there that are saying, oh, I use this in industry. You know, these sensors, it's really cool. I do this. And so there's this interaction between the public to the students that's been a real benefit for our students. So in summary, I just want to mention what's the future of engineering education. You can go to regular lecture calls, especially the big lectures. I don't like those at all. I think it's wonderful to be able to replace, especially big lectures, with things where we have personalized education where the students are really interacting with the instructors. And then you take a lot of the more mundane stuff and you put it online and have them watch that part and take any of the really serious things at the high level thinking and put that in the classroom. Lectures where they're going to have a lot of questions, put that in the classroom. Put the more mundane things online where they can learn at their own speed. Okay, that's the end of my little presentation.